We're in the middle of this incredible AI arms race to build the most powerful systems imaginable. It's exciting for sure. But that's only half the story. The other half, the much, much harder half, is actually making them safe. And right now, there's this dangerous gap between those two goals, a gap we absolutely have to bridge before it's too late.
So that brings us to the big question, right? As we keep cranking up the power on these AIs, are we also making them more predictable? Or are we just building these incredibly powerful tools that we can't fully control? That's the real tension at the heart of AI development today.
And that tension, well, it's there for a reason. It's because the world of AI safety is basically split down the middle. You've got two different camps working on the exact same problem, but they aren't even speaking the same language. It's a fundamental disconnect in how we're even approaching safety itself. Okay, so on one side, you've got the alignment researchers. They're asking these huge philosophical questions like, how do we get an AI to understand and adopt human values? Then on the other side, you have the risk engineers. They need concrete, testable rules. They're thinking about things like fault tolerance and failure modes. And right there, that's the problem. You can't run a diagnostic test on a philosophy. So to really get why this disconnect is so critical, we have to look at the main method we're using for AI alignment today. Because once you see how it works, you'll see why it's basically a flawed mirror, and why that is just not good enough when we're trying to engineer our future. The industry standard is something called reinforcement learning from human feedback, or RLHF. Here's the gist. We have an AI generate a bunch of responses. Then a bunch of humans score them, thumbs up, thumbs down. And the AI learns to produce more of the stuff that gets a thumbs up. It basically learns to please us. But this creates a huge problem. The AI becomes what you might call a digital mirror. See, it doesn't learn a set of principles or ethics. It just learns to mimic the preferences of its human raters. And that means it learns to mimic everything about us, including our biases, our blind spots, and all of our inconsistencies. And this digital mirror has some pretty critical design defects. Not only does it soak up our biases, but it's also totally unpredictable when it hits a new situation it hasn't seen before. And most importantly, for any engineer, it's a black box. You can't just pop the hood and inspect the code to find the ethics. You can only judge the output after it's already happened, which, let's be honest, is way too late. And this really gets to the heart of it. To build a safe bridge, an engineer needs a blueprint, right? A specification. But with AI alignment, all we've been giving them are observations. It's like asking them to build a skyscraper by just watching other ones stand and kind of hoping for the best. So how do we finally create that blueprint? Well, the solution is a totally new approach called constitutional AI, and it's designed to be the engineering bridge that finally connects those vague human values to concrete, testable rules. Constitutional AI, or CAI, really represents a fundamental shift in how we think about this. We're moving away from the abstract, philosophical hope that an AI will just learn to be good, and we're moving toward the concrete engineering practice of giving it explicit instructions on what good actually means. And the process is actually really elegant and simple. First, humans write a constitution, a document with clear principles. Then, and this is the cool part, the AI critiques its own responses against that constitution and revises them to comply. Finally, the model is trained on its own corrected answers. It literally teaches itself to follow the rules we gave it. And the difference is just night and day. We go from a vague, fuzzy goal like be harmless to a super specific rule like do not assist in any way with cyber attacks. And the result is no longer this unpredictable feeling of safety, but a verifiable, predictable behavior. It becomes something you can actually engineer. And this is where it gets really transformative. This new approach completely changes how we think about accountability. It takes us out of the darkness of that black box and into the light of a clear, measurable, and auditable process. This changes everything. Seriously, we're no longer trying to guess what's happening inside the neural network. Instead, the Constitution itself, a readable, human-written document, is the thing we audit. Regulators, engineers, the public, we can now inspect the rules before the system is ever deployed. And because we have rules, we can actually test against them. This lets us create hard metrics for safety. We can calculate something called a constitutional error rate. For instance, we can say with confidence that the model violated a specific clause in only 0.02% of our thousands of stress tests. That's a real number you can put in a safety report. Now think about what this means in the real world, maybe legally. When something goes wrong, the old defense was basically, well, the AI learned from a huge data set and we kind of hoped for the best. The new CAI defense is, we explicitly forbade this behavior in Clause 17 of our Constitution, and here is all the test data to prove it. That is the difference between hoping and engineering, between negligence and actual due diligence. So this takes us from a purely technical solution to a really practical one for governance. Constitutional AI isn't just some cool concept for a lab. It's a tool that can become the actual cornerstone for how we write real-world policy for artificial intelligence. And, check this out, it's not just a theory. It maps directly onto the gold standard for AI governance, which is the NIST framework. You need to govern. The Constitution is your explicit policy. You need to map risk. The clauses define the boundaries of what's acceptable. You need to measure. Now you can actually quantify how well the AI adheres to safety rules. And manage the system? You just edit the Constitution. It's a perfect fit. So at the end of the day, the big takeaway is this. We finally have a path forward. We can stop hoping our AI is safe and start engineering it to be safe, with real, auditable rules that help ensure it behaves exactly the way we intend. Which brings us to the final and maybe the most important question of all. Now that we have the engineering capability to give our AI a real rulebook, what's the very first rule we should write? That's the conversation we all need to start having.